Okay, good morning. This is the first part. I'm going to explain a little project that I've been working on, which relates to radios. So this is here a pet food dispenser that we have for our dogs, and it's remote controlled with this little key remote that we have. So push the button, and it dispenses a few treats for our dogs. So the issue we have with this is that it came with only one remote, and it's one of the problems is, try as I might, I could not find another remote for it. So try to determine what kind of frequency this uses, and we could see okay. The first step for me was to try to figure out what kind of radio frequency and what kind of modulation it uses, and then try to reproduce it. So I've been working with this Arduino platform, of course. Okay, so this is part 2 of the little project. So as I said, the first thing is to determine what frequency this remote is using and what kind of signal. So to that effect, there's this amazing $25 device, okay, which is basically what they call the software-defined radio receiver. They're initially designed to really be a terrestrial TV receiver for a computer, but what it does is it can tune to any frequency up to 1.8 gigahertz or so, and across that frequency it can digitize basically the signals with a 2.4 megahertz bandwidth. So you pick a frequency, and let's say we think it's 433 megahertz here, and then I'm gonna press the remote, and there you go, you see the signal show up. Now this free software here, you can record the signals and analyze it using like an audio editing software, and from there we can figure out what kind of modulation it was. This is part 3. So now using this audio editing software, I can open up the file, and this file here will contain actually the what is called an image frequency recording. So basically the software samples the demodulated signal around the frequency that we picked, which was 433.310.000 hertz, and then you can see that the signal from the radio is actually composed of 39 identical pulses. If we zoom into one of these pulses, we see that the pulse itself contains a set of ones and zeros, you know, with spaces and so on. So when we look at this, we can see that a typical radio will have a preamble, which is an alternating 1 and zeros at the beginning, a certain number of them. Then there will be basically the data packet, which is some amount of data. One thing I notice here is the modulation is frequency modulation. If you look again at the frequency spectrum during the transmission, you can see 2 spikes. There is one that's centered at the frequency that I picked, and another one at a higher frequency, and the deviation between the two is really how much frequency shift you will have between a 1 and a 0. So that's one important factor. The second one is really the format of the data packet, which means the number of preamble bits, 1s and 0s, and then whatever that data is, how many bytes, and what the actual data is. So our goal now is to reproduce this signal. Me to the last part. So we have here little modules that are quite amazing. This radio module, the little green stamp size module in there, is an RFM69HW module, which is centered on a 433 megahertz band, and it's a transceiver, so this is an overkill for what we're doing here, but basically we can choose the modulation format, we can tune the frequency to pretty good accuracy to what we want, we can choose the frequency deviation, modulation format, etc. And it actually also contains a packet engine, so we can program the microcontroller to send the proper packet to this radio and have it transmitted. So after a lot of work, which I'm going to skip over, I found the correct packet format to reproduce exactly what the remote was sending, correct modulation, etc. And now it's working. So this program here will send only one signal when it resets. So I'm going to push the reset button and we're going to look at our radio transmission reception here. There we go. And of course, this is here we cannot see, but I can record it exactly in the same way and compare the signal with what the remote was sending. And also, of course, the real test is to make sure that the receiver over there in the kitchen is working and receiving that signal and interpreting it as if it was sent from its original remote, which it does. So that concludes my little explanation. This glossing over a lot of work here, but what I'm trying to say is that basically using the microcontroller and these radio modules, we can, with some work, reproduce a radio signal from a remote and activate the device. Alright, that concludes it. Thank you. I could not resist to show the thing in action, so here it is. Now it's plugged into an outlet adapter, and here is the pet dispenser. Let's push the reset button here and look at this. There we go. The little delay is just the time it takes for the microcontroller to initialize. Alright, thank you.